Hey everybody, this is Larry. This is day 18 of the Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's problem and today's video and everything. Keep in mind that, maybe not keep in mind, but today I will do an extra question, a random question, problem. So definitely hit the bell and do another problem with me if you've already done this one or something similar. Yeah, I was also ready to kind of hit the reset button because I feel like recently it's just been on my cookie. Or I don't know where they store this, either in local storage or on the server or something. Probably my local storage, but uh, but yeah. So I'm just ready for that. But yeah, today's problem is 918 maximum sum circular subarray. So given a circular integer nums, return the maximum possible sum of a non-empty subarray of nums. I feel like we did this problem like very recently. I feel like we did this problem really recently. Well, I mean, I know that probabilistically it's probably not the same problem, but I just don't know that or why. Well, I don't know. I mean, it's fine. It's probably not the same problem, but they're very similar problems. So the idea, and this is something that comes up from time to time in competitive programming, this idea, maybe you could call it a trick, maybe you could call it an observation. One thing that you can do with these circular array problems, and you know, these things it's something that comes up, but it's not something that might happen every time, right? It may happen, it may not. But what I mean is that you can kind of double the array. Why does that work? I mean, and you don't even have to do it that way, but it just makes the math a little bit easier. And I think last time it wasn't this problem probably, but on a similar problem, I doubled the array physically. But I think this time I'm going to try to do it with the matrix just to be a little bit more clear. But you can think about it as doubling the array. After you double the array, then you just have to do some maths to make sure that, you know, this is not longer than that, right? And that's pretty much it. After that, if you have this array, well, you can kind of think about the conditions, right? The only condition, because then now, actually, does that work? Yeah, okay. I just want to double check the constraints before do anything silly. But I think the idea, and this problem is based off knowing, what is the I'm forgetting the name right now. The max subarray. So there's one where it's not circular, right? There's a maximum sum subarray with the negative numbers, obviously. Otherwise, you just stick them that way. But and I forgot the algorithm's name. I haven't done it. Kendo's. Wait, is it? I'm gonna Google this. Kadane's. Okay, I had a K. It doesn't come up that often, and I guess it hasn't come up in a while. But yeah, but definitely try to look up. I mean, it's probably a Leetcode problem. I probably should have just like find a link for it. But if you have struggled with this one, definitely work on this one first. And spoiler alert, I guess I already kind of gave you the answer. Look up Kadane's algorithm. There are a couple of ways to interpret Kadane's algorithm. Some people kind of just do it in a rote rate in that they just memorize it. But the way to kind of think about it is just dynamic programming. And I'm not going to go over it that much in this particular video. Definitely go. I mean, I probably have a video on this anyway. You know, I have thousands of video at this point, which is actually kind of fun to say out loud. Thousands of video. So it's not, but also to those of people who are, you know, always wondering how many problems I solved. I haven't kept track in a while, but I have solved at least a couple of thousand, even just on YouTube itself, right? So, you know, take it as it will. And by then, I already have solved thousands of problems. So anyway, so my suggestion here is just, you know, get basically, yeah, and maybe, I don't know if I have to think, I mean, I have to think about this a little bit, but maybe you can kind of do a sliding window thing after that, right? Like, if it's yeah, you do a sliding window after that, and that should be fine, right? Uh, yeah. Hmm. I am trying to think whether I'm like overthinking this, because I feel like today I'm having some struggle kind of proving this in my head to be right, and sometimes that will happen. But you can also just do it with sliding window, maybe. Hmm, I don't know, because I'm trying to think whether that would be maximal. But no, 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 no. Okay, I see how this works, kind of. The sliding window thing is a little bit interesting, actually, right? Because you always slide one sub array. So that means that the number that you're sliding will always be exactly the same number that you're adding, and therefore it will never change the answer. And that's why you don't need the sliding window, and that's why Kadane's algorithm worked for this circular subarray. Does that kind of make sense? Basically, and if it exists in a way such that the entire because if you have the length of the subarray, meaning you have n elements that sum up or that is just positive in general, then that is your answer anyway. Because, well, that means you literally use all the numbers in the array, and also, I do wonder if there's something like. I mean, it doesn't have to be your best answer, but it could be an answer, right? I wonder if, like, let's say I'm just thinking in my head. Wow, I thought this. I mean, this is not a hard problem, but I'm just like trying to overthink a lot of these cases, right? So something like this, say, in this case, oops, in this case, this will give you a 1, and then this will just have an entire array anyway. Okay, fine. But that's not the maximal sum, right? The maximum sum will be this part, right? So how do you do? So with Kadanes, you go to 1. How did past Larry do this? Did I just make like an assumption and didn't really explain it? Maybe today I'm just having issues. Okay, because this goes to 1. Right, this goes to 1. This goes to 21, right? Or whatever. It's still positive, and then add 6. But then now we have to take away this 6, right? But then how do you? I mean, of course we can just pop the 5, but I mean, I guess there isn't. I mean, I could figure out an algorithm about this, but I'm trying to think in my head to prove it correct. Because then therefore, for this problem, you need the sliding window again, right? Because you only want like these 3 things, and then Kadanes would give you a 1, and then just all the numbers, and then that's like 21. But then that's not quite enough for it to be the right answer, right? And actually, that's example 2. All right. I mean, it may not be. I feel like there's a easier answer. I think that's why I'm like. That's why I'm like struggling a little bit with it. But I would also say, I mean, sometimes you have good days, sometimes you have bad days, and I'm doing these live for that reason. But I wouldn't say even a bad answer. I mean, if it works and the complexity is roughly the same, maybe extra space in this particular case, if I do it this way, it's probably okay. That is a little bit awkward though. But in any case, the doubling the array thing still makes sense. It's just that there are some cases I have to figure out. Oh, and you have to have at least one element. Okay, that's fair. I mean, and this one is Kadanable. And of course, you don't want to do it in you don't want to do it in a way such that you make it an n squared, and I don't think we need to. Okay, I mean, I'm kind of trying to still think about it. So best is, at the very least, you can take one number, so that's our default answer. And then for I in range of 2 times n, let's just write out the basic Kadanes first. So current is equal to 0, current num sub I mod n, right? And then if current is less than 0, current is equal to 0, right? Best is equal to max best of current, something like that. And that's Kadanes, but it's not going to be right for case 2, as you know, this is the same thing that we have here, right? Just kind of write it out. I mean, I don't think there's an infinite loop. Why is it so slow? Okay. Yeah. Expected 27. How did I get 42? That's not even close. Oh, I didn't do the thing where wow, I'm even worse. Oh, I just forgot to do it. Where yeah. Well, I think I'm just overcomplicated things a little bit. I think certainly Kadanes could be used to solve it, and we can do it this way. I think I kind of overcomplicate things. So this is Kadanes, you know. So not taking the circular way. The thing with the circular way is just that is, how do I say it? The way with the circular way is that the suffix plus some prefix, right? Yeah, I mean, I think that should be good enough for me to kind of do it another way. So this is the whatever. Let me run it just to make sure that it is what we expect, and that is true. That's the Kadane answer. Okay. And then now the other part, I think I overdone it. I mean, maybe we could have still done it that way. I think there's also a way where, you know, you take the sum and then minus the best negative number or something like that. And that's because that's the maximum in the middle. So then you subtract it or something like that, right? Maybe we could do it that way. So that way, I think that works in that, okay, so maybe you have something like S is equal to sum of nums, and then right, and then, you know, best is equal to max of best, Kadane of nums, and then maybe something like best negative is equal to max of, oh no, whoops, you don't need max. Just say Kadane, oops, negative x for x in nums, right? And then now, so then, what they call S minus best negative. So best is equal to max of best, and then this thing. That's a little bit awkward, but fine. Huh. Does that not give -3? Or 3. Hmm. I think maybe we have to reverse negative it. That's why. Okay, maybe not. Hmm. Oh. That's because it tries to do all the numbers. That's why this doesn't work with that one. Okay, which is fair, but how would I solve for that case? Oops. Hmm. Basically, you don't want this to have all the numbers for -1. Okay, so that is actually tricky, isn't it? Huh? I mean, the idea kind of makes sense, but then now we're not doing the case where I mean, maybe we could do an example here, but I feel like I don't know that I have a good edge case here. Maybe I should have done the other thing, just sliding window. Sliding window would have been fine, or even the prefix suffix thing. I think this is just the prefix suffix thing anyway, right? You take the best of the suffix and then the best of the current thing, right? I don't know. Maybe it's too late to do it. Maybe not, but how do I make sure that this has at least that uses at least one number? Because basically it just tries to take everything on the negative side. Okay, so this is almost right, but because I was gonna say no. If there's a positive number, let me try to play around with this case. If there's like a positive number, then it's would I be right? Yeah, then I would be right, because I want to say something like, because if there's at least one positive number, the best negative won't be a negative number. Okay, so I could do something like if all of if there's any positive number, oops, yeah, then we do this maybe. I think that maybe cuts it out. Let's give it a submit. Hopefully I didn't miss a case. Okay, cool. 10:23. Oh, look, pretty good running time. This one was kind of harder than I expected, but I think that's actually that's funny though. But it is a teaching moment, I suppose, because I think at the top of the video I did say something like, "Ah, it's a circular array. We're gonna just add a thing," but apparently you don't have to. And in fact, it kind of confused me for a bit because I was trying to figure out. But that said, you can also just use the prefix suffix thing, so it's not a big deal. But as soon as I kind of got away from the circularness, or like the trick, if you will, it actually wasn't that bad. But yeah, and this is going to be linear time, constant space. I mean, technically I made a list, but you can actually rewrite this such that it doesn't use the list and it just keeps the generator, which takes no more extra space. But I kind of was lazy. You can write something like this, and then instead of this, it'll just be something like that would be constant space with generator, right? So yeah, so if you want to optimize it that way. But yeah, like I said, linear time, constant space. That's all I have for this one, probably. Let me see what I did last time. What did past Larry did? Past Larry used stacked. Okay, so this is basically what I was probably saying. Wow, what did past Larry do? Okay, so we use Kadanes for this one. We go for the Kadane, and then we go backwards. Man, I have no idea what I did in here. I'll have to look at what past Larry video. I'm guessing that I probably did the prefix suffix thing in a really funky way, but yeah. I hope the prefix suffix thing made sense too, because I don't know that I talked about that much. But basically, Kadanes is for getting stuff in the middle, and then the only other way that it is optimal is that you can pre-calculate the Kadanes on a suffix on a DP kind of way, and then as you go from left to right, you kind of just take the best answer from the suffix and then add it together. So that would be the other way of doing it, but maybe I could have done that one as well. I don't know. Anyway, that's all I have for this one. Let me know what you think. Stay good, stay healthy to good mental health. I'll see you later and take care. Bye bye.